Good morning, students.
Good morning, sir.
Hello, please put your attendance in the command window. Please put your attendance in the command window. രാകേഷ് ഇന്നലെ എവിടെ പോയി?
ഇന്നലെ നെറ്റ് ഇഷ്യൂ.
Okay. Okay, students, in the last class, we have completed our all modules, that is 1, 2, 3, 4, and 5. First two modules are completed by Rahul sir, and then third module, half is completed by Rahul sir, and another half is completed by me. Fourth and fifth module also completed. So today onwards, we will go to revision. For that, first of all, we will do the last problem, the last part, that is theory of failure, because we have a good remembrance about these equations. So we will do some problems on that this class as well as afternoon. We will continue problems on theories of failure. This will help you to get good marks in your academics, because a lot of different types of problems are doing in this, and you have to check all those parameters. And whenever you are speaking something related to theory of failure, first of all, you must think which are the theories of failure. That's the first part. What are the theories of failure? How a material will fail? There are three chances of failure of material. First one depends on stress, second one depends on strain, and third one depends on energy. And according to that, the first term, that stress, may be failed by two methods, that is principal stress theory and shear stress theory. The principal stress theory is also known as Rankin's theory. Shear stress theory, also known as Guess theory. And next one is principal strain theory, and this is also known as Shen-Venance theory. And then comes distortion energy, strain energy theory, that is known as von Mises theory. And finally, maximum strain energy theory, also Hay theory, also discussed in the last class. Most of the equations are familiar to you, and according to those theories, we are going to explain the problem. So we have to write a problem, and for that, I'm giving you a problem. Please write down the problem. No need of writing the solution. The question is, please take your notebooks. The question is, the load on bolt consists of, the load on bolt consists of, the load on bolt consists of an axial pull, an axial pull 10 kilonewton, 10 kilonewton, 10 kilonewton, together with a transverse shear force, together with a transverse shear force, together with a transverse shear force of 5 kilonewton, of 5 kilonewton, of 5 kilonewton. Find the diameter of bolt, find the diameter of bolt required according to താഴെ എഴുതുക. One is maximum principal stress theory, one is maximum principal stress theory, second one maximum shear stress theory, first one maximum principal stress theory, second one maximum shear stress theory, second one maximum shear stress theory, second one maximum shear stress theory, third one maximum principal strain theory, third one maximum principal strain theory, maximum principal strain theory, maximum principal strain theory, fourth one maximum strain energy theory, maximum strain energy theory, maximum strain energy theory, and last one, fifth one, maximum distortion energy theory. Maximum distortion energy theory. Maximum distortion energy theory. Take permissible tensile stress at elastic limit. Take permissible tensile stress at elastic limit. Take permissible tensile stress at elastic limit. Take permissible tensile stress at elastic limit equal to 100 megapascal. 100 megapascal and Poisson's ratio 0.3. 0.3. This is the problem given to you. Hope you have written. So first of all, you must know you have to compare with the previous problems. In that, sigma x, that is stress, is directly given in the problem. Sigma x, sigma y, and tau xy. But here, when you are looking the problem, there is no stress is directly given. Only forces are given. That is, there is an axial pull, and that is given as 10 kilonewton, and transverse shear force as 5 kilonewton. So from these, we have to determine stresses. And for that, we have an equation: stress is equal to load by area. But when you look here, the determining quantity, we need to determine diameter. So diameter is unknown. So we cannot directly find diameter. So first of all, you write what are the given data. First one is axial pull, that can be expressed as PT1 or XPX. It will be nice to write PX or PT1, no issue. That will be 10 kilonewton. And transverse shear force is given as 5 kilonewton. And there is a permissible tensile stress at elastic limit. Here, instead of yield point, they have given elastic limit. There is no change. You can use the same. So, but you cannot write it as sigma YT. Instead, you have to write it as sigma T bracket EL. That is the only change. If the elastic limit is given, we need to take all the loads within the elastic limit. So that is given as 10 megapascal. That should be converted into Newton per mm square. Hope you are aware of units. A 1 MPa is equal to 1 Newton per mm square. That's important. 1 megapascal equal to 1 Newton per mm square. And what is the case of Pascal? That is the basic unit. 1 Pascal is equal to 1 Newton per meter square. There is a difference. If you don't know, please write down. 1 Pascal is equal to 1 Newton per meter square. 1 megapascal equal to 1 Newton per mm square. There is a difference. So both are to be memorized because in the upcoming semesters you need to use megapascal as well as pascal units continuously. So as a mechanical engineer, whenever you are doing something, you are calculating something, you should remember the units and the unit of megapascal, how to convert that into Newton per mm square or Newton per meter square or Pascal to Newton per meter square should be known to you. So 1 Pascal is equal to 1 Newton per meter square. 1 megapascal is equal to 1 Newton per mm square. So you can write it as sigma TEL is equal to 100 Newton per mm square because all the data we are going to study here is in mm. Also, the Poisson's ratio is given as 0.3. That should be written here. And diameter, we can take it as small d, which should be determined. So first of all, you need to write the area equation, that is A is equal to pi by 4 d square, or pi by 4 can be expressed as 0.7854 d square. This term is known to us. And we have tensile stress. Since it's only acting in single axis, so we can take it as axial pull as sigma x, that will be PT1 by A, or PT1 is equal to 10 kilonewton, and that can be converted as 10 divided by area, which is given here in the terms of D. And substituting that one, you will get 12.73 divided by D square, and unit should be remembered, that is kilonewton per mm square. You can convert into Newton per mm square by multiplying it with 1000, that will become 12,730 divided by d square Newton per mm square. And transverse shear stress can be found out as tau xy equal to ps by a. Ps also given in the problem. You can directly substitute the values and the terms in txy also we will get. Please write down till now. If you have any doubt, you can ask me now. Don't copy everything. If you have any doubt, if there are any mistake, there is no problem. Mistakes are good. Then only we can correct it. If you are copying everything means you cannot understand anything. So you do by your calculator. These kind of problems are very important. So please write. Please write with your calculator. You need to use your calculator. You need to speed up your calculations. Then only you can get good time balance in your examination. Have you completed? Can I go to next slide? Please respond.
Yes, sir. Complete.
Thank you. So first of all, you need to do with maximum principal stress theory. For that, we need to find maximum principal stress. That is sigma 1. And for that, you have an equation that is sigma 1 equation, as well as you need to find minimum principal stress that is sigma 2. Both should be found out. The only difference is change in sign. And if you want, you can take all 1 by 2 outside. In the last problem, we have taken like that. So if you take 1 by 2 outside, that will become 1 by 2 into bracket sigma x plus y plus root of sigma x minus sigma y square plus 4 into tau xy square. And when you are looking the problem in the question, previous question, that you can see that sigma x is available, tau xy is available, and there is no load is acting on the y direction. It is not mentioned in the problem, so we hopefully thinking that there is no load is acting on the y direction, so we can take y as 0. We are only having sigma x and tau xy, so y will become 0, and here also y will be cancelled. So final equation will become sigma x by 2 plus 1 by 2 root sigma x square plus 4 into tau xy square. Then you need to substitute the value of sigma x in this equation, that is 12.73 divided by d square. The unit is kilonewton per mm square. Since we are all taking all the unit in kilonewton per mm square, we kept like that because 12,730 square means that will be a very huge value. That's why we are doing like this. If you do in Newton per mm square, then also it will be correct. But all the terms should be in Newton per mm square. After substituting this one, you have to find the values. That is 12.73 divided by 2 will become 6.365. And also you can take 6.365 by d square from both this equation. Then the equation will become like this, and solving everything, the final term will be 15.365 by d square kilonewton per mm square equal to ഇതിനെ ന്യൂട്ടണിലേക്ക് കൺവേർട്ട് ചെയ്താൽ 15365 divided by d square. This is the final equation according value of sigma 1, that is maximum principal stress. And according to maximum principal stress theory, we have equation as this should not be greater than sigma TEL or sigma yield. In actual equation, that is given as sigma yield. Since the maximum condition given in this problem is elastic limit, so we cannot exceed stress beyond elastic limit. So you need to substitute sigma 1 value here with equating with sigma EL. Also see that there is no factor of safety given in this problem, and they didn't ask about any factor of safety. So if you substitute as a factor of safety, that will not be a wrong statement, but since it's not given, you can take factor of safety as 1. That's better. So solving this equation, you can directly find the value of D. This is the method of solving diameter. So please write down. If you have any doubt, you can ask me.
സാർ അവിടെ എങ്ങനെയാ റൂട്ടിന്റെ ഉള്ളിൽ 4+4 വരുന്നത്?
4+4 വരുന്നത് എന്താണെന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇതിനകത്ത് ടോട്ടലായിട്ട് 6.365 പുറത്തേക്ക് എടുക്കാം. അതിന് ഇങ്ങനെ ചെയ്യണമെന്നില്ല, ഡയറക്റ്റ് ഇതിനകത്ത് നിന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തോ. ഇവിടെ ഈ 4 ഇവിടെ വരുന്നുണ്ട്, ഇവിടെ ഇല്ലതിൻ്റെ അകത്ത് 2 ഇൻറ്റു 6.365 അല്ലേ ശരിക്കും പറഞ്ഞാൽ 12.73. 2ന്റെ സ്ക്വയർ ആണ് ഇവിടെ 4 വരുന്നത്. ഡയറക്ട്ലി ചെയ്താൽ ദാറ്റ് വിൽ ബി ബെറ്റർ, നോ പ്രോബ്ലം.
ഓക്കെ.
Please tell me once you complete. Do with your calculator. Don't copy the values. Have you completed? Please tell me once you write down. Please use your calculator. You need to find the values by your calculator. This is an important theory, and only by doing this problem you can pass the examination. As mentioned, you should careful while taking sigma x, sigma y, and tau xy. And we have 5 theories. The first theory is maximum principal stress theory. According to that, we have determined the diameter. Now you need to go to the second theory. What is the second theory? What is the second theory?
Shear stress.
Yeah, shear stress theory. Have you completed this slide? Yagesh, have you completed?
Yes, sir.
Okay, I am going to the next theory. So, according to principal stress theory, we have the value of diameter as you can see 12.4 mm. So now we are going to the second theory, that is according to maximum shear stress theory. And for that, we need to find the value of tau max. In the previous case, we have find out the value of sigma 1, that is principal stress. And now you need to find the value of maximum shear stress. For that, you have the equation tau max equal to 1 by 2 root sigma x minus sigma y square plus 4 into tau xy square. And we have another equation for finding tau max. Either you can use this equation or another one, that is, what is that equation? Do you remember what is that equation? Tau max equal to, are you remembering this equation? No response. How you will pass? Please respond. Do you remember this equation? Naveed?
Yeah.
Yeah. This is the equation we should be remember, because tau max having two equations. One is 1 by 2 root sigma x minus sigma y square plus 4 tau xy square, or sigma 1 minus sigma 2 divided by 2. But in the previous case, we have found out sigma 1 directly. So if you know sigma 2, that is sigma x plus y divided by 2 minus 1 by 2 root sigma x minus sigma y square plus 4 tau xy square. That is here change in sign only, we will get sigma 2. Then you can directly find tau max. So you can use either that one or this one. After solving that equation, you can find the values of tau max. Since here, when you are looking the problem, as in the previous case, there is sigma x, but there is no force in y direction. That's why sigma y will become 0. Sigma y will become 0 because there is no load in the y direction. And also you need to substitute shear force, that is tau xy. And after substituting the values, that is sigma x tau xy will be there, sigma y will be 0. And after substituting this one in the terms of d square, the final term will be like this. And solving this equation, when you are solving this equation, don't copy this one. I am showing this equation for your preference, but you need to find out by calculator. I will check this one when you are coming to college, as well as we will do some module tests when you are coming to college. On that time, you have to do very fastly. You cannot wait some time for doing some problem. And after that, you can get Tomax in terms of d square. That is 9 d square kilonewton per mm square or 9000 d square Newton per mm square. And the second theory, that is maximum shear stress theory, says that tau max should be equal to sigma TEL divided by 2. What is TEL? That is tensile elastic limit. So normal equation is sigma YT, that is sigma yielding, but here maximum conditions given as sigma TEL, as I have mentioned in the starting of problem. And when you are substituting this one, you will get tau max equal to sigma TEL by 2 is equal to 9000 by d square. That is the value of tau max equal to TEL given in the problem as 100 megapascal or 100 Newton per mm square. And substituting this value, you will get the value of D. That is, when solving D, you will get that is 13.42. Please do with your calculator. There may be error because it's a question from the textbook. So don't believe that this is the correct answer. Do yourself and find it. Don't copy. Use your calculator. എടാ എഴുതി കഴിഞ്ഞാൽ പറയണേ.
Ah, ഇതന്നെ വരുന്നത് 13.41.
കറക്റ്റ് തന്നെയല്ലേ?
Ah,
Okay. Then according to next theory, what is that third theory? I won't show the slide. You need to do yourself. What is the third theory?
maximum principal strain theory.
Yeah, according to maximum principal strain theory, what is the equation? Just look behind. You have to check the notebook. You have already written all these things.
Epsilon max equal അതല്ലേ?
Yes, epsilon max, and epsilon max is given as sigma 1 by E minus mu into sigma 1 by 2. അങ്ങനത്തെ equation അല്ലേ വരുന്നത്? Yeah.
mu into sigma 2 by E.
This is the final equation, that is here, look here. Sigma 1 minus mu into sigma 2 equal to sigma TEL, right? There is no sigma 3, that's why the equation should cut down. And there is no factor of safety given in the problem, so you can write the equation as such. And first of all, you need to find sigma 2, and after that you need to find the relation. I will not show you. Find the value by maximum maximum principal strain theory, and find the value of diameter. Not only Naveed, ബാക്കി എല്ലാവരും ചെയ്യണം. Sarang, please give the answer of this question. Third type. Sarang, can you hear me? Sarang, കേൾക്കാമോ? അപ്പൊ ഇതിന്റെ ആൻസർ നീ ടൈപ്പ് ചെയ്ത് തന്നാൽ മതി. ഫൈനൽ ആൻസർ, വാട്ട് ഈസ് ദ ഡയമീറ്റർ ഇൻ ദ തേർഡ് തിയറി, ദാറ്റ് ഈസ് മാക്സിമം പ്രിൻസിപ്പൽ സ്ട്രെയിൻ തിയറി. സ്ട്രെയിൻ തിയറിന്റെ ഇക്വേഷൻ എന്റെ കയ്യിലുണ്ട്. യു ഹാവ് ടു സബ്സ്റ്റിറ്റ്യൂട്ട് ദാറ്റ് തിങ് ആൻഡ് ഡയറക്ട്ലി റൈറ്റ് ദ ആൻസർ ഹിയർ. Sarang, got your answer? Do it. Only you need to substitute sigma 1 and sigma 2. What is the value of sigma 2? Just tell me the value of sigma 2.
അത് സീറോ അല്ലേ എടുക്കണ്ടേ? സീറോ.
2 എങ്ങനെ സീറോ ആവുക? സിഗ്മ എക്സ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്ന പോലെ തന്നെ ഇതിനകത്ത് നേരത്തെ ഇക്വേഷൻ സിഗ്മ 1ന്റെ അകത്ത് ഇവിടെ മൈനസ് കൊടുക്കുമ്പോൾ സിഗ്മ 2 കിട്ടാം.
അതപ്പോ സിഗ്മ 2 നമ്മൾ കാണണം.
സിഗ്മ 1ഉം സിഗ്മ 2ഉം ആണ്. സിഗ്മ 2 സീറോ അല്ല. സിഗ്മ 3 സീറോ ആണ്, കാരണം അത് തന്നിട്ടില്ല. സിഗ്മ വൈ ആയിരുന്നു സീറോ, നോട്ട് സിഗ്മ 2. ഈ ഇക്വേഷനിൽ സിഗ്മ വൈ സീറോ ആണ്. അതേപോലെ സിഗ്മ 2ന്റെ ഇക്വേഷൻ എടുത്താലും സിഗ്മ വൈ സീറോ ആയിരിക്കും. സിഗ്മ 2 will be there. There will be minimum principal stress. Sigma 1 will be there, mu will be there, sigma 2 will be there, and sigma yield will be there. From that you can directly find diameter. മർസോക്ക് അറ്റൻഡൻസ് പറയുന്നതിന് മുമ്പ് ആൻസർ പറ. Sarang, have it find the answer. Sigma 2, at least sigma 2. In terms of d, I want the top value. Bottom side will be d square, right? Whenever you are answering to a question, that will include your marks. I will give preference for the exact answers or response. Even that is wrong, no issue. Please tell the answer. Now we are not having that much time. that we will do now directly. When you are doing the problem, sigma 2 will be in the terms of negative. Whether this is the correct answer, you have got this value, Naveed?
ആ കിട്ടുന്നുണ്ട് 2636
Okay, 2635 minus 2635 by d square. So when you are substituting the value in the maximum strain energy, principal strain energy theory, that will become minus and minus plus. Okay, there will be sigma 2 minus, and here there is a plus signal. So the final answer will become plus value. So when you are solving D, the final value will be 12.7 mm.
അവിടുത്തെ ബൈ ഇന് എന്ത് ചെയ്ത്
രണ്ട് സൈഡിലും ഉണ്ടാവും ബൈ ഇ. ഈ ഭാഗത്ത് ഇ ഉണ്ടാവും, ഇവിടെ ഇ ഉണ്ടാവും, ഇവിടെ ഇ ഉണ്ടാവും.
മൈനസ് സിഗ്മ ഓക്കെ ഓക്കെ ഓക്കെ
All terms having e in the all sides, so you can eliminate that one. Since e is not given, if e is given, you can directly substitute the value. We will continue this problem in the afternoon. Now we are not having that much time. That is according to maximum strain energy theory as well as distortion energy theory. So we will discuss it in the afternoon. So please write down your attendance right now. എടാ ഇങ്ങനെ എല്ലാം കോപ്പി ചെയ്തിട്ട് കാര്യമില്ല കേട്ടോ. കോപ്പി ചെയ്തതിനെ കൊണ്ട് പാസ്സാവാൻ പറ്റില്ല. അത് ശരിക്ക് സ്വന്തമായി കാൽക്കുലേറ്റ് ചെയ്യണം. തെറ്റിയാലും കുഴപ്പമില്ല, തെറ്റിയാലേ ശരിയാവുള്ളൂ. അലനുണ്ടോ?
ഇത് 12.7.
Yes.
12.7.
12.7. Roll number 6 ഉണ്ടാവും. അറ്റൻഡൻസ് ഞാൻ വായിക്കാം, അതായിരിക്കും നല്ലത്. പെട്ടെന്ന് അങ്ങ് തീർക്കാലോ, നോക്കിയെടുക്കാൻ കുറച്ച് ബുദ്ധിമുട്ട്. അഭിനന്ദ് ഉണ്ട്, ആദർശ് പ്രേമൻ ഉണ്ട്, ആകാശ് ദിലീപ് ഉണ്ട്, അലൻ ഉണ്ട്, അമർനാഥ് ഉണ്ടോ?